In my last couple of videos, I've been talking about TryHackMe, and I've gone over a couple of the labs in the Junior Penetration Tester learning path. Last time I took a look at the Intro to Web Hacking section, and I completed the first lab in that section, which was walking an application. I wanted to make at least one more video out of this section because I feel like a lot of the tools and techniques that they talk about in this section is really useful if you want to be like a web application pen tester or anything like that. Unfortunately, a lot of the labs in this section do require that subscription to TryHackMe, but one of the pretty good ones that is actually freely available is the one all the way down at the bottom, which is SQL Injection. Now, I think I made a video about SQL Injection a while back, which was when I was doing the Burp Suite Web Security Academy courses. So if you want more SQL Injection stuff after this video is over, feel free to go back and look at that one. But since SQL Injection is such an important thing to know how to find and to look for when you're doing a pen test against a web app, I figured it's okay to do another lab covering that topic. Now, if you don't know what SQL Injection is, they give you a little introduction at the very beginning in this first task. It says that it is an attack on a web application database server that causes malicious queries to be executed. When a web application communicates with a database using input from a user that hasn't been properly validated, there runs the potential of an attacker being able to steal, delete, or alter private and customer data, and also attack the web application's authentication methods to private or customer areas. This is why, as well as SQL Injection being one of the oldest web application vulnerabilities, it also can be the most damaging. So if you are a complete beginner and have never heard of SQL Injection before, they do a pretty good job of explaining it in these first few tasks here. And at the end of each one, they ask you a pretty simple question just to check if you actually read the information. For example, the first one just asks what SQL stands for. And you can see right here at the top, it is Structured Query Language. You can copy that, paste it, submit, and you got your first answer. So if you've never heard of SQL Injection, you can go through these first few tasks and read them and get a pretty good basic understanding of what it all is, like the difference between a relational and non-relational database. And in task 3, it tells you how these databases are structured in these tables. And then in task 4, it gives you a little rundown of what SQL Injection is and how that works. And once you have that basic understanding of how SQL Injection works, now we get to task 5, which is the first actual practical lab where we're going to start looking for some flags. So first, we need to click the Start Machine button. It'll take a few minutes for the machine to start up, but once it does, you can open it and it'll show you this first level 1 error-based SQL injection. And if you read the notes over on the left side, it says level 1 of the practice lab contains a mock browser and website featuring a blog with different articles, which can be accessed by changing the ID number in the query string. As you can see over on the right, there's article $ID equals 1. And if we change that 1 to a 2, now we can see that the article changed and we're seeing some different content in this little mock web browser. Then it says the key to discovering error-based SQL injection is to break the code SQL query by trying certain characters until an error message is produced. These are most commonly single apostrophes or a quotation mark. So let's try putting in a single quote. And over on the left, you can see that it says the fact you've received this error message confirms the existence of a SQL injection vulnerability. We can now exploit this vulnerability and use the error messages to learn more about the database structure. Then it says the first thing we need to do is return data to the browser without displaying an error message. First, we'll try the union operator so we can receive an extra result of our choosing. Try setting the mock browser's ID parameter to 1 union select 1. So now we're getting error messages which are going to tell you a little bit more about the structure of the database. And this is why it's recommended for applications to return generic error messages, not to give this sort of information to attackers that might be trying to exploit your application. But since we know that we have the wrong number of columns, we're just going to add 2. So now we have a second column instead of just 1. We still get the same error, so let's add a third column. Now we see that it is returning content and we're not getting that error, so we have the right amount of columns. But if we keep reading the instructions, it says, now we want to display our data instead of the article. The article is being displayed because it takes the first returned result somewhere in the website's code and shows that. To get around that, we need the first query to produce no results. This can simply be done by changing the article ID from 1 to 0. Instead of 1 union select 1, 2, 3, we're going to do 0 union select 1, 2, 3. Now we see that it took that 1, 2, 3 that we put in there and it input it into different places within the database query. But now we want to get some actual information about the database itself returned in that query. So now instead of 1, 2, 3, we're going to replace that 3 with database. And now we see that it returned SQL I_1. And that is the name of the database. And now that we have that name, we can use that to create more queries to give us more information. So over in the instructions, it shows us this command, group concat table name from information schema.tables, where table schema equals SQL I_1. And they give you a little breakdown of what all these commands do. So group concat gets the specified column from multiple return rows and puts it into one string separated by commas. That way it can return that in a readable format that we can look at on our screen. The next thing is the information schema database. Every user of the database has access to this, and it contains the information about all the databases and tables the user has access to. In this query, we're interested in listing all the tables in the SQL I1 database. So now we're going to use that information with this command to get the names of all the tables within that database. So I'm going to copy that into our web browser, and I'm going to submit that. And now it returns article, staff users. So those are the names of the 2 tables within that database. So I don't think we really care that much about the articles, but if we take a look at the table called staff users, that might give us some interesting information that we wouldn't have otherwise. So we're going to use another group concat command, and we're going to say from information schema.columns, where table name equals staff users. So we're going to get the names of all the columns inside the staff users table. And it returned ID, password, and username. So there are 3 columns within that table, and the one that should immediately catch your eye is password. So if we're able to access the contents of this database table, we can get the passwords of all of the staff users. And we're going to say group concat username password, and we're going to separate it with a BR, which is an HTML command just for spacing, from staff users. So I paste that command, hit enter, and now it returns admin password, Martin password, Jim work 123. So those are our 3 staff users and their passwords. And you can see down here in the bottom right, it says, what is the user Martin's password? And we can see right here from this table that we just dumped, we can see that it is password with 2 $signs. And once you submit that correct password, it moves you on to level 2, and it shows you the flag at the top of this page. So we can copy that flag and paste it in here and submit. And we just got our first flag for this lab. Now we move on to level 2, which is on blind SQL injection. So for this lab, they help you out by actually showing you the SQL query that corresponds to what you're submitting. But obviously in a real scenario, you wouldn't have that, and you would just have to figure it out based on the response from the website. But for example, if you put in test for the username password, you see that here's the SQL query that it's submitting with test in those 2 fields. And then if you click login, the results is no results found, and since no results were found, it's not going to let you log into the website. But in order to get that query to return successful, you just need to get it to respond true. It doesn't actually need to find a real username and password. You just have to get the database to say true, and then it should accept your request. So instead of submitting a real password, I'm going to submit a single quote or 1 = 1 semicolon dash dash. So if you look at the SQL query, you see that the password is empty, but it also says or 1 = 1. And because 1 = 1 is always true, and I'm using an OR operator, which means that only one of them has to be true in order for the whole statement to be true, it's going to return true no matter what. And I put in the semicolon and the dash dash, which is a comment operator in SQL, so that this part of the query that was supposed to be sent is just going to be ignored by the database. So now when I click login, it says you bypass the login and can move on to the next level. And after I click level 3, it takes me to level 3 and it shows me the flag here at the top. Once again, I can copy that and paste it and submit it. And there's my next flag. So now we're on to level 3, which is a Boolean based blind SQL injection. So we can see that we have a couple little mock web browsers here. And this first one has username equals admin, and then it says that taken is true. So this is pretty similar to the kind of functionality that you might see on a lot of websites where you're creating a new account and you're asked to create a username, and the username that you give it is already taken. So then it says taken, and then you have to put in a new username, and you might have to put like numbers at the end of it or whatever until it tells you that is not taken, and then you can use that username. So we can see here in the example they give, it says admin is taken, but if we do admin123, that is not taken. But just like we did back in level 1, we're going to try to do some SQL injection here. So the first thing we need to do is use that union command to find the right amount of columns. So we're going to do single quote union select 1, and then our semicolon dash dash. So we can see down in the bottom that they have the SQL results, but they are not actually printing that out to the web browser, so we can't see it. That's why this is a blind SQL injection, because we just have to go on what they give us and we have to figure it out as we go. But because the result of taken is false didn't change, we can assume that we do not have the right amount of columns yet. So just like before, we're going to keep adding columns until something changes. So you can see once we got to 3 columns, the taken went from false to true. So now that we have the number of columns, we want to find the name of the database just like we did back in level 1. The only problem is, in level 1, we were getting results from that database query directly in our web browser. But now we're not getting that input, so we're going to have to work a little bit harder in order to find out the name of the database. So once again, we're going to use that database command. But instead of just looking for the database, because we're not going to be able to see the results of that, we're going to use like quote percent, and that percent is just a wildcard character. So that's going to return true just because that matches anything. So no matter what the database is named, it's going to match it. But if we were to run that again with an A at the beginning of it, then that's going to match everything that starts with A. For example, if the name of the database was admins or something like that, then it would return as true because it would match that A and then a wildcard. So if we run that, it says false. So now we know the name of the database does not start with A. And we can run through the entire alphabet until we find the first letter of the name of the database. In reality, you would most likely use an automated scripting type of tool, like something like Burp Suite or SQL Map or something to do all this. But it is good to figure out how to do this manually so you know what those automated tools are actually doing. I won't bore you with going through the entire alphabet one by one to do all this, because we do know the answer based on what they tell us over on the left side instructions. But just imagine that I did go through all the entire alphabet until I got to S, and then when I submit that, it returns true. So now I know that the database name starts with S, and then once I know that, then I can find out what the second letter is, and I can run SA false, SB false. Pretend that I went through that entire alphabet through all those letters to figure out what the full name of the database is, and eventually I find out that it is SQLi_3. And when I run that command, I get a true, so now I know the name of the database. And once again, back like we did in level 1, we need to find the names of the tables within the database, and then we need to find the names of the columns in the database. And once again, we're going to run that command we used before, which is from information schema.tables, where table schema equals the name of that database that we just found, and table name like A, and then the wildcard. Because once again, we have to go letter by letter and figure out the name of those tables. And if I run A, then I can tell that there is no table that starts with the letter A. And then once again, I go through it letter by letter like we did before until I find a table. Again, I'm not going to bore you by going through that whole process because it's tedious, and we do have the answer over on the left side. Assume we went through that whole process though, and we found a table named users. And when we run that command, we see that it says true, so we know that we do have the correct name of that table. And again, that tedious process we have to go through again with the column name like and the wildcard in order to find the names of the columns within that users database. And if you keep reading, you see that right here, because you could have multiple columns in that table, you want to be able to find all of the different columns. And say, for example, you find that there's a column named ID. Once you know that first column, you need to find the other columns. So you're going to add column name exclamation point equals ID. So you're just going to remove that from all your results. That way you can go through that alphabet again to find the rest of the columns and not be finding ID again. And once you go through this whole process, you will find that there are 3 different columns: ID, username, and password. So because this query is vulnerable to that blind SQL injection, and we can find a valid username, we can use that SQL injection to brute force their password. So to do that, we're going to use this command, union select 123 from users, which is the table, where username, which is the column within that table, equals admin, which is the username we're trying to brute force the password for, and password like, and then we're going to use this wildcard functionality again to brute force each character of that password. Because we can kind of cheat by looking over on the left, I'm going to, instead of running it with A, I'm going to replace that with a 3. And that says true, so now we know that the first character of the password is a 3. Say I do 38, which we know because we're cheating over on the left side, but assume that we were doing this by 1 character at a time, going through the whole alphabet and numbers and special characters. But if we do 38 and then that wildcard, we get true again, so we know the first 2 characters are 38. And then we go through that whole thing until we find that the entire password is 3845, which is a horribly insecure password, but what can you do? So now we go down to the login form and we're going to put in admin as the username and the password as 3845. Click login, and that takes us to level 4 and it gives us the flag at the top. Once again, we copy and paste that over here, submit it, and now we got another flag. So now we come to the last of these SQL injection challenges, and this one is going to be a time-based blind SQL injection, which is probably the most difficult to find. So over on the lab, once again, we have a mock web browser, and it has this URL that has a refer equals, and it has tryhackme.com as the refer. And it has a little timer that shows that it took 0.001 seconds to complete. But if we add a single quote, union select, and then this sleep function, and then tell it to sleep for an extra 5 seconds, and then submit that query, first we can see down the bottom that we're getting an error because we don't have the right number of columns. So we have to go through that whole process again of finding the right number of columns. We've done this a few times now, so it shouldn't be that new to you. We're going to add a 2. And that time it actually responded, and we can see that the response time was 5 seconds. So using that sleep command, we were able to add 5 seconds to the response time. So now we have to go through that process that we've done a few times now, where we find the name of the database, and then we find the name of the tables in the database, and then we find the names of the columns within the tables. So once again, we're going to have to use that wildcard functionality to brute force all of those names, but this time we're not even going to have that true or false to tell us whenever we get anything right. The only thing that we're going to have is the actual time that it takes to respond. The way we'll know that we're right is it's going to take an extra 5 seconds. If we get it wrong, it should respond within 0.001, 0.002 seconds, something like that, very quickly. But if we get it right, that sleep 5 part of the command is going to execute, and it's going to take an extra 5 seconds to respond. Just based on the naming convention that we've seen in previous responses, I'm going to assume that this is probably going to start with S, because most of the databases have started it with SQL. But if we try that with the S and then the wildcard, we see that it's taking a little while longer to respond, and it took over 5 seconds, so we know that we got that first letter right. It's probably going to be SQL_4, because that's just the naming convention they followed, but you can see that if we didn't know that, we could just brute force it one at a time like we did last time. So my first goal is to find the column in the database table that has the users. So I'm just going to assume that that's probably going to start with user or username or users or something like that. So I'm going to see if I can find a table that starts with U. And eventually I get users, and I think that is going to be the column that I'm going to look at first. So now that we have our table name, now we need to find the columns. And because for this login form, we need a username and a password, I'm going to assume there's probably going to be a username column and a password column. So first I'm going to try U, and I keep doing that process until I find the column name username. And I can verify that by, instead of doing like, just doing equals, and I get a 5-second request time, so I know that I do have the correct column name. And if I repeat that process again to find the column where the passwords are stored, if I run the command with a P and then that wildcard, again, it takes over 5 seconds to respond, so I know that I'm on the right track. And eventually I end up with a column name password. So I know that there's a column named usernames, and I know there's a column named password, and I can use SQL queries to find the corresponding values to a valid username. So first we need to find a valid username, and a pretty good safe place to start is admin, because most websites have an admin username or something similar, administrator, something like that. So I'm going to run the command where union select sleep5, because we need that sleep5 in order to know when we get a query correct or not. And then we're going to do from users, which is the database table name, where username, which is the column name, equals admin. So we just want to verify that the admin user exists. And when we run that, we get a greater than 5 seconds request time. So we know that is a valid query, and we know that there is an admin user. And then we're going to brute force the password to that user by using the same method that we used in our last lab. So brute forcing each one of those characters, we find that the password is 4961. Fortunately, they're just using a 4-digit password and only numbers, so it was much easier to brute force than some real-world passwords would be. So now that we've brute forced our database to find a valid username and password, now we can put in those values into the login form and log in. Once we do that, it takes us to the next screen that says training complete, and it shows us our last flag. So now we've completed all the SQL injection labs, and there are a couple more tasks, but these are just more informational about out-of-band SQL injection and then remediation of SQL injection. But it would be a good idea to read through this information, and then you can submit the answers at the bottom of each task in order to get the points in TryHackMe. But that's pretty much it for this SQL injection lab. Like I said at the beginning, I have covered SQL injection a little bit before when I was working with the Burp Suite labs in the Web Security Academy. So if you want more SQL injection, feel free to check that out. But I really liked the way that TryHackMe presented this. Again, you would probably be using a automated tool like Burp Suite or SQL Map or something to do this in real life. But it is a good idea to be able to do this manually, especially for some of those more complex ones like the time-based SQL injection, because those are sometimes not very easily discovered with those automated tools. But I hope these videos are helpful to anyone that might be a beginner and kind of on their journey to becoming a professional in the cybersecurity world.